Eddie and Eileen have decided to invest $16,000 for their 8-year-old son Gary. He is to be given the money on his 20th birthday in 12 years' time. They have chosen a savings fund that pays interest at the rate of 4.8% per annum, compounded quarterly, so that's 4 times a year. So if that's 4 times a year, then that's going to be 4.8 divided by 4, so that's 1.2% per quarter. The following table shows the value of the investment at 3 monthly intervals during the first 2 years, 3 monthly being quarterly. So we can see the 12% interest being applied here. The value of the investment at the end of each 3 months or quarter can be written as value equals A times 1.012 to the n, and we can actually see this calculation in the table, for example, just here. What is the value of A? Well, A must be the initial investment, which we know was $16,000. What is the value of n after 2 years? So n is the number of compoundings, and there's going to be 4 of those in a year because it happens quarterly. So for 2 years, n will be 8. What is the quarterly interest rate? We worked that out before. That's 1.2%. Determine how much Gary will receive on his 20th birthday. We were told he was 8, and so he would receive it in 12 years. So that's going to be 12 times 4 is equal to 48 compounding periods. Then using a calculation of this type, we can do 16,000 times 1.012 to the power 48. So we'll just calculate that. Let's go back to main. So 16,000 times 1.012 to the power 48. And we want to give this in dollars and cents, so that's $28,365.12 if we round it. So we can say $28,365.12. Write a recursive rule for the value of the investment after n quarters. The clue we have here are the calculations in the first part of the table. So we can see 16,000 is the beginning, so that's got to be T0. Remember, that's part of a recursive rule. So T0 is equal to 16,000. Then what do we do to that? We multiply it by 1.012, and that will give us T1. And then we take T1 and multiply it again by 1.012 to get T2. So what we can say is that Tn is equal to the one before Tn minus 1. It does say n quarters, so we need to have n just here. The one before is Tn minus 1, and we're multiplying that every single time by 1.012.